In this question, we are given that the electron is set into an oscillatory motion by the electric field of a laser of the given intensity, and we need to find the displacement and velocity. So in order to solve this problem, we need to solve first the equation of motion. The equation of motion from the second Newton's law can be written as F is equals to mass times acceleration, and that can be written as charge into the electric field. Now the electric field, let's assume the electric field is in the x direction and the wave is propagating along the z direction. So the electric field can be written as E is equals to E naught sine omega t minus kz. So the equation of motion becomes m into a is equals to q E naught sine omega t minus kz. A, the acceleration, is equals to dv divided by dt. So dv by dt will be equals to the charge on electron is E, so E into E naught divided by m sine omega t minus kz, multiplying dt on the right hand side, we will get dv is equals to E naught divided by m sine omega t minus kz into dt. Integrating on both sides, we will get v is equals to minus E naught divided by m cosine omega t minus kz divided by omega. So v will be equals to minus times E naught divided by m omega cosine of omega t minus kz. From this expression, we see that the amplitude of velocity can be written as v naught is equals to E naught divided by m omega. Let's say this equation is equation number 1. Now to calculate v naught, we will need the E naught and omega. E naught is simple, the relation between intensity and the amplitude of electric field is I is equals to 1 over 2 C epsilon naught E naught square. So E naught square will be equals to 2I divided by C epsilon naught. So E naught will be equals to square root of 2I divided by C epsilon. Putting the values, we will get square root of 2. The intensity was given 150 watt per meter square divided by 3 into 10 to the power 8 into 8.85 into 10 to the power minus 12. One can solve this expression to get the amplitude of electric field to be 3.361 into 10 to the power 2 Newton per coulomb. Now what will we do for omega? Omega is simple, omega is equals to 2 pi nu. Nu is the frequency. Now the relation between frequency and lambda is 2 pi c over lambda. Now omega will be equals to 2 pi into 3 into 10 to the power 8 divided by the wavelength, and wavelength was given 554 nanometer, that means 10 to the power minus 9 meters. So omega will be equals to 6 pi divided by 554 into 10 to the power 17 radian per second. Now putting back these values in the expression of V naught, what will we get? V naught is equals to E naught divided by m omega is equals to 1.6 into 10 to the power minus 19 into what was the value of E naught, that is 3.361 into 10 to the power 2 divided by mass of electron 9.1 10 to the power minus 31 into 6 pi divided by 54 into 10 to the power 17. One can solve this, use expression to get the amplitude of velocity, that will turns out to be 1.73 into 10 to the power minus 2 meter per second. That is approximately equals to 1.7 into 10 to the power minus 2 meter per second. Now the second part of this question is to calculate the amplitude of the displacement, and one can get this from equation 1. The equation 1 was V is equals to minus E naught divided by m omega cos omega t minus kz. So V will be equals to dx over dt. So equation 1 can be written as, from equation 1, dx over dt is equals to minus E naught divided by m omega cos omega t minus kz, multiplying by dt on the right hand side, you will get dx is equals to minus E naught divided by m omega cos omega t minus kz into dt. Integrating on both sides, you will get x is equals to plus E naught divided by m omega square sin omega t minus kz. This term is the amplitude of the electron, so the amplitude will be equals to E naught divided by m omega square, and notice that it is equals to V naught divided by omega. So we have the expression for V naught. The value of V naught was found 1.73 into 10 to the power minus 2 divided by the value of omega was calculated before, and that was 6 pi divided by 554 into 10 to the power 17, and after solving we get the value of A to be 5.1 into 10 to the power minus 18 meters. So the results are, the amplitude is equals to 5.1 into 10 to the power minus 18 meters, and amplitude of velocity is equals to 7.1 into 10 to the power minus 2 meter per second.